Okay, so Unit 4 is going to be mostly over solving systems of equations. So we're going to first start with systems of equations of two variables. So first off, a system of equations is denoted by the little squiggly bracket over there on the left. And basically it ties these two equations together. And so what it says is that all the x's have to be the same, all the y's have to be the same. So this one you can look at and just solve it in your head, that for an x plus a y to equal 5 and an x minus a y to equal 1, it'd be x equal to 3 and y equal to 2. Okay, that's just solving in our head. So let's go over methods of how to solve it where it isn't so easy. So the first method we're going to talk about substitution. Since all the x's and y's are the same, I can substitute into the other equation. So let's say I take the second equation here and I solve for x. I would get x equals 1 plus y. So if I substitute that into the other equation, okay, we have x plus y equals 5. We said x is 1 plus y. Okay, so then we have 1 plus 2y equals 5, or 2y equals 4, which gives me y equals 2. Then I can substitute in to solve for the other variable. I can do x plus 1, x equals 1 plus y, which is x equals 1 plus 2, or 3. So the solution is x equals 3, y equal to 2. Okay, let's do another substitution. Let's say I have the system 3x plus y equals 13 and 2x minus 5y equals negative 14. Now when we're solving these, we can plug in, or we can solve for any variable in either equation and plug it into the other equation. So you can see that the easiest thing to solve for is right up here to solve for y. So that would give us y equals 13 minus 3x. So if I substitute that into the other equation, y is 13 minus 3x. Okay, so I have 2x minus 65 plus 15x equals negative 14. So it gives me 17x minus 65 equals negative 14, or 17x equals 51, x equal to 3. And then I can substitute in for y over here to solve for, or substitute x in to solve for y. So I have 13 minus 9, or 4. So the solution is x equal to 3, y equal to 4. Okay. The other method we're going to talk about is called elimination. Okay. On elimination, if we know all the x's and the y's are the same, we can add the two equations and the x's and y's are still going to be the same x and y. So in this case, you see how I have opposites right here? If I add these two, they're going to cancel out, which got rid of a variable, which is what we want to do. So we end up with 2y equals 8. So then we can solve for y, and then we can plug that into either one of the two equations and solve for x. It doesn't matter which one. Okay, so the solution is x equal to negative 2, y equal to 4. Let's do another elimination. Oop. Okay, so on this one, you see I don't have opposites that'll cancel out like on the last one. But right here, if I multiply by negative 2, it becomes negative 6x minus 10y equals 14. And I can do that because if I multiply everything in the equation by a number, the same number, then it's still the same equation. It's just been multiplied by something. And so then if I add those two, now it eliminates, and I get negative 12y equals 24, which gives me y equals negative 2. And again, plug it into either one of the equations. I'll use the second equation this time. I get 6x plus 4 equals 10. 6x equals 6, or x equal to 1. So the solution is x equal to 1, y equal to negative 2. Okay, so I only had to multiply one equation on that one. Let's do another one. Okay, in this case, we don't have any opposites, and I cannot multiply just one equation to get opposites. In this case, I have to multiply both equations. So let's say I want these guys to equal negative 6. 6 and negative 6. So I can multiply this guy by 2. That would make the leading term 6x. I can multiply this guy by negative 3 to make the leading term negative 6. If I do that, I get 6x minus 8y equals 2. And negative 6x minus 9y equals negative 36. If I add those together, I get negative 17y equals negative 34. And divide both sides by negative 17 to get 2. Plug that into either one of the two equations. Get 3x minus 8 equal 1. 3x equal to 9, x is equal to 3. Okay, now let's talk about some special cases. Let's look at this system. Okay, so on this one, I need to multiply here by 2 to make that first term 6x. So we get 6x minus 4y equals 8. And then over here we have negative 6x plus 4y equals 7. Now you see that everything cancels on the left-hand side, but I get 15. But this is not true. Okay, 0 does not equal 15. What ends up happening with these two equations is two lines. These become parallel lines. So they never intersect. So we have no solution for those two. So we call this an inconsistent system, and there is no solution. Okay? That's any time you end up with 0 equals some number. It's not some untrue statement. Okay? Another special case. Multiply this bottom part by 2 to make it negative 8. So we get negative 8x plus 2y equals 4. You end up with 0 equals 0. Now this is a true statement, but why did everything cancel? It's because those are the same line. They just are multiplied by a different multiplier. Okay, so in this case we call this a dependent system. And it's not no solution because they're the same line. Every x and y that satisfies one equation also satisfies the other. So we say there's infinitely many solutions. Okay? So we'll stop there.